Hello everyone. Today I will be presenting my review on CoMAT, the change of mathematically annotated thought, an approach designed to improve mathematical reasoning in large language models. My name is Sarah Ladino Komi, and this presentation is part of my fellowship AI reading group. Here is an outline of today's presentation. We'll start with an overview of CoMAT, discuss its objectives and how it works, and then move into a demo of some sample questions, comparing CoMAT with chain of thought methodology. Finally, I'll share insights on what we learned and some key takeaways from the project. This figure provides an overview of the CoMAT framework, outlining the structured process CoMAT follows to reach the solution. The framework is divided into three main stages: symbolic conversion, symbolic formalization, and reasoning execution. Starting with the question, CoMAT first undergoes symbolic conversion, where it translates the problem into logical symbols and structures. This includes defining relevant variables, functions, and predicates that represent the question's components mathematically. Next, it moves into symbolic formalization, where the logical symbols and variables are formalized into a complete symbolic representation. This step prepares the question for reasoning by ensuring all symbolic elements are properly defined and organized. The third stage, reasoning execution, involves applying logical operations to systematically work through a problem based on the established symbols and formalized expressions. In this stage, CoMAT uses step-by-step reasoning, adhering to the rules and relationships defined in the symbolic stage. Finally, after executing the reasoning steps, CoMAT reaches a final answer that satisfies the symbolic condition of the problem. This structured approach enhances interpretability, accuracy, and transparency at each step in the reasoning process is logically derived from the defined symbols and rules. Let's start by looking at the challenges CoMAT addresses. Standard LLMs often struggle with math problems because they lack structured logical reasoning. The widely used COT approach has helped, but it is constrained by limitation of natural language, which can sometimes be ambiguous. CoMAT proposes a solution by introducing a two-stage symbolic reasoning approach, allowing LLMs to structure and solve problems without ambiguity. So how does CoMAT achieve this structured reasoning? It works in two main stages. First, CoMAT converts the natural language problem into symbolic representations such as equations and logical expressions to eliminate ambiguity. Second, CoMAT processes these symbols through structured reasoning, which ensures that the model follows accurate mathematical logic without needing external solvers. The image illustrates symbolic convergence stage of CoMAT framework, breaking down the process of understanding and structuring a problem using logical and mathematical reasoning. The question involves a concert scenario where Taylor Swift is planning a tour. The venue capacity is 50,000 and there are two types of tickets, VIP price at $250 and regular price at $100. If the total revenue from the ticket sales is $6,500,000 and all tickets are sold, the goal is to find how many VIP tickets were sold. Identification and definition. In this step, the variables and constraints are undefined within the problem. For example, here, variables are V, VIP tickets, and R, the regular tickets. Constants is sold capacity, T equal 50,000, and the VIP ticket price, which is B sub V, which is equal to 200, and regular ticket price, B sub R, 100, and total revenue R capital equal 6,500,000. Structural logic translation. In this step, the problem is structured into logical equation to reason constraints and relationships. V plus R equal T is the total number of tickets sold, which matches the venue capacity. B sub V dot product V plus B sub R dot product R equal R capital. Total revenue is calculated based on ticket prices and quantities. Explicit factual. In this step, translates known values into a format useful for problem solving, laying out values for each parameters. Question formalization. The problem is formalized into a specific mathematical query. Find V, the number of VIB tickets sold, given the constraints derived from previous steps. The symbolic conversion process leads to a clear, formalized problem representation, preparing it for the reasoning phase where logical steps can be applied to find a solution. So here, the reasoning execution stage of CoMAT, where CoMAT applies structured logical steps to solve the formalized problem derived from symbolic conversion stage. The previously derived formalization equation, V plus R equal T, and V sub V dot product V plus V sub R dot product R equal R capital is brought into this phase, creating a foundation for applying step-by-step reasoning. CoMAT employs structured solver to address the problem systematically, guiding through each logical step. The process here is laid out in a clear step-by-step approach. Step 1, rearrange the capacity equation R equal T capital minus V to express the number of regular tickets in the terms of VIB tickets. Step 2, substitute R equal T capital minus V into the revenue equation to create a single variable equation. V sub V dot product V plus V sub R dot product T capital minus V equal R. Step 3, simplify the equation by distributing terms and combining like terms, reducing it to an equation that only depends on V. Step 4, solve for V by isolating it on one side of the equation, which yields V equal 10,000, indicating 10,000 VIB tickets were sold. Final answer. The calculated number of VIB tickets 10,000 is confirmed as the final answer, emphasizing that the structured CoMAT approach has led to a clear and accurate solution through logical regression. Now the demo. We just regenerated the GitHub repository and took one example from the research paper and run the code. The example is from the MMLU-Redux elementary mathematical dataset comparing code and CoMAT. Here is the example. The distance between Miriam's house and David's house is 444.44 meters, which statement about the values of the digits and the distances in meters between their houses is true. And there are options laid from A to D with specific conversion of these values. First, we define the question. I will just show you the code. Okay, so we first applied this prompt of the MMLU-Redux, the elementary, and to see if we can regenerate the same examples of the research paper. So each option represents a hypothesis about the relationship between digits in different decimal places, giving us basis to evaluate CoMAT symbolic reasoning in COT step-by-step logic. So here's the execution. CoMAT results, as you can see here, includes symbolic processing, parsing the problem into logical steps, and methodically analyze each option. So let's look at CoMAT's output. The approach defines variables, applies place value analysis by expressing each digit value in the specific place. CoMAT walk through options step by step, identifying both option B Okay. And as you can see here, I'll just show it all. So here CoMAT identified option B and D are valid based on symbolic calculation. In this scenario, CoMAT selects only B because it adheres to the selection rule of choosing the first valid option. Uh, the results for code isn't the same as the research paper. Here the code chose D. Let's go back to the conclusion. So what we have learned here is in our analysis, we observed several advances and limitations on CoMAT. On the positive side, CoMAT offers improved accuracy, transparency, and reliability without relying on external solvers. It also works well across various models and languages. However, it does come with some limitations such as higher computational costs and performance plateau on simpler tasks. Additionally, its effectiveness relies heavily on the quality of symbolic conversion, making it less practical for non-math problems. So, in conclusion, CoMAT shows significant promise for enhancing mathematical reasoning in LLMs. The accuracy improvements and logical transparency it offers makes it a valuable tool for mathematical and logical heavy applications. That said, balancing computational cost with effectiveness will be key for its broader adoption. Thank you.